Hello guys, this is T-Port Guides and this is our logical operations. I'm going to just give you guys a quick logical operations tutorial on how to calculate AND, XOR, or the logical shifts within Java. I've already done a tutorial on this, which is located in my part 5 in the Java Associate tutorials. So if you have a quick look at that, you should get all of these anyway. But I haven't actually included how I've how some of the logical operations work. So I'll just quickly go over the AND and XOR and OR. I'm not going to go through the plus and multiplication and all that because those are straightforward, and if you don't really know how addition or multiplication works, then you shouldn't really be going into Java and trying to program in Java. Okay, so the AND statement, we need to first always remember the AND truth table. And the AND truth table looks a bit like this. So we've got two inputs, and 0 means false and 1 means true. So if on our first input we've got false, second input false, then our output in the final statement would be false as well. The only true we would get if A and B are set to true, then our output would be true. Given an example of this and writing a Java code would be, let's say for example I've got a int a, let me just say int port equals to 35, and then system dot out dot print ln, then let's just say a equals a, no not a, port equals port plus no and 3. Okay, you might be thinking, okay, so 35 and 3, so it means 38, but that's not how it works. What we need to do here is we need to write these numbers in these order. We need 1, 2, 4, 8, 16, 32, 64, and 127. Okay, now that we've got these, what you need to do now is you need to 35. How would you get 35 in the binary form? So what we would do is what we would do is we need what we need is a to get 35. If we get a, we don't need a, we can't get, you work from left to right, so no 127s. You can't have a 64 because it will be over 35. 32, yes, we can have that, but our remainder would be 3, so we can't have the 16. We can't have that. We can't have that. Yeah, we can have that, and we can have that. So that will give us 35. Now what you need to do is go underneath it and write 3. So these would all be 0, 0, 0, 0, 0, 0, 0, 3. Okay, and now you need to look at your logical table. So 0 and 0 here would give us an output 0. So what you do here is write 0. 0 and 0 again gives us a 0. 1 and 0. 1 and 0 give us 0 again. And then this is 0. This is 0. This is 0. This is 1. And 1. And now you've said that you want 1, 2, and 1, 3. So the system what it needs to print out there would be actually 3. What you would get from the printed would be 3. So this is what the result would be. Now the XOR works a bit similar to this, but the truth tables are different. The truth table would be this is true, and this is true, this is false. And let's just say again with this, and the sign of it is the sign of XOR is this. That's what the sign of XOR is. So you need to do the same thing what you did with AND, like write 35 here, which we've done, and then 3, which we've done, and then here this final result what would be changed. So it would be 0 0 1 0 0 0 1 and 1. So 1 and 1. So this would give us 35. So your final answer should be 35 printed out. The logical shifts, how they work is, if we was to say by 3 to the left, so we've got this, we write 35 here first, we write 35, and then we logically shift this, so this would go you have to 3 places, so it'd be 1 2 3. So you need to delete 3 from the left hand side, okay, and our answer would be 24. So once the system is printed out, it'll print out 24. That's what it will be printed out. So the right shift is basically the same by 3. Let's just say we want to shift this by 3. So it will be delete these 3 from there, and put 0 here, 0 0. So what you would get here would be 3, because look, you've got 2 and you've got 1, so these two, you're only taking 2 and 1, which added together equals 3. And the OR gate, the OR thing, not the gate, the logical operator in Java, it's a single thing like this. It's this, and the truth table changes as well. The truth table is this. It's not the same as XOR, is that, and this would be, so you need to write 3 here, so it'd be 0 0 0 0 0 0 0. No, it's 3. So 1 1. So we made up 3. So looking at this again, we would only get 3. The answer would be 3. But this has to be 35 actually. So yeah, this has to be 35. This has to be. So what we would get is not actually, it's 35. Yeah, 35 is the answer. So 35 would be printed out. Okay, this is it for this tutorial, guys. Please subscribe to my YouTube channel, and if you have time, look at my other YouTube channels, videos. Thank you.